Greetings world and welcome to another problem. This one is number 28, implement strStr, and it was a problem given by Google in a coding interview. Now, a couple of words that I want to say before we actually start. I am using a new program to record, meaning that from 30 FPS, we're actually going to jump to 60, and the video should be a lot more smooth. Now, that's something that I'm very excited of. The video quality should be, again, Full HD, so we don't have any improvements there. And the audio, I think that is going to be a little bit better, at least I do hope. And a very nice, neat feature new that we have is that we can actually draw on the screen. And you can see what I'm drawing, because before you only saw this part and I couldn't really do anything. I had to start recording again when I was in Paint and then start recording again when I was in LeetCode. And that was a bit tedious to work. So now I can just draw whatever I would like, and it's going to be easier to see. Okay. So before we actually start, they gave us a string here, a reference, a link. I'm going to open it. And here they want to show you what strStr does in C++ and in C. So if I open in C, function is only declared as this instead of the two overload versions provided in C++. So let's edit and run here and see what are we actually expecting to have. So here we have the string. This is a simple string. Then we have a pointer, and we're going to say strStr of the string, and we're going to search for simple, I suppose. And it's going to give us the index of simple onwards, meaning that when I put or printf on the screen, I'm just going to get. And I do end up writing I don't know why they put string here. Let's go with PSH. I'm going to get sample string because I already received the index of this bytes over here. And then I'm going to place everything onwards. Now, if I delete that, since here we're copying 6 bytes, the first 6 bytes we're replacing with sample, I should get simple string. And that's pretty much what we need to achieve, but in C#. So let's close the two windows over here and start reading the problem. So we're given two strings, needle and a haystack, and we need to return the index of the first occurrence of needle and haystack, or -1 if needle is not part of the haystack. Clarification questions. These are very nice to ask if you have not understood what exactly are you required to do. What should we return when the needle is an empty string? This is a great question to ask during an interview. So here they say that nobody tells you anything in the explanation. What should you return if the needle is actually empty? And now when I think about it, the haystack can be empty as well. So what do we return when the haystack is empty and the needle is empty? Do we return 0? For the purpose of this problem, we will return 0 when needle is an empty string. And this is going to be consistent to C and Java. All right? So then we have the examples. Hello. And with the two else, we're going to return index 2 because 0, 1, 2. This from here, we can see some occurrence of the needle. Now I do want to write it, and I do want to test. The control alt D. Yes. Okay. Good. Now let me go with red color. I think that's going to be better. And now I'm just going to show you the hello and the LL that we're searching for. So this is going to be the needle over here, and I think this is going to be very thick. I don't want it like that, so let me just change. How do I change? Okay, I guess we're just going to go with this thick one. Right, so the first thing that we need to do is, if we start iterating, the intuitive solution is, if we start iterating through hello, and I'm going to go with green now. So if we iterate here, H, E, L, and as soon as we actually find something that is the same as the first letter in L, then we need to check if the last letter, so we are going to have a range, and we're going to check if the last letter of our range is equal to the last letter. It is, and then, and only then, we know that we might have a chance at finding the needle in a haystack, and the loop is going to occur, meaning that I'm going to have, let me go with the different here. So I'm going to have L here, and I'm going to have L here. So both of them are actually equal, meaning that I am allowed to move next. Then I'm going to have L here, and I'm going to have L here. both of them are equal, so I'm going to move next. Then I'm going to get O here, and here I don't have anything, meaning that I'm going to break. And now I'm just going to keep a count of how many equal characters do we have in each string. So here we have 2, and obviously here we have 2 as well. So the 2 characters, oops, let's go back. So the 2 characters are equal. And now what's left for me to do is to say, is needle's length 2 or more than 2? If it's more, so I don't have space here, but if it's more, so if needle was actually 3 and we found only 2 letters that are the same, meaning that I have not found the needle, and if the needle is 2 and here we found 2 characters that are the same, it means that we have found the needle. So that's pretty much my solution. Let's go and code it up. All right, the first thing that we want to do is the control flows. Now the control flows are actually, you can find them here in the clarifications. And I'm going to say if string is no or white space, and what string is no or white space needle, I'm going to return 0. This was over here. For the purpose of this problem, we will be returning 0 when needle is an empty string. Also, how do I know if a needle is never in the haystack? Well, if needle.length is bigger than haystack.length, it means that I'm never going to be finding the needle in the haystack length. It's not physically possible. And that's pretty much it. Next, we can start writing the algorithm. Now, I'm going to go with starting index here. And I'm going to make it equal to be 0. Then I'm going to say needle end. Actually, needle. Yeah, I'm going to go with needle end index. Is going to be equal to our length minus 1. Then I'm going to go with end index. That's going to be our haystack.length minus needle end index. Now, end index is going to be this because I can never exceed the needle range, right? If the needle's length is bigger than the haystack, it means that I'm never going to find it. So that's why I do say here the end index is going to be equal to the haystack length minus the needle end. And now I'm going to iterate while the starting index of both is less than the end index. All right. Once again, let me just Control-D over here. Go with red. If I'm left with, for example, LL, for example, and I have LLO, if I end up being here, there's no need for me to go because we don't have enough characters to actually compare to the needle, meaning that I have not found the needle and the needle is not present. So here I'm just going to be returning -1. All right, so that's pretty much it. Now, interesting is, here's the interesting part. So I need to check if the first letter of the needle is actually equal to our haystack of starting index. So here what I'm doing is I'm having the needle being, LL. I'm going to write it like that. And I'm going to iterate the haystack. And here, if I have L, that's going to be equal to the first occurrence of L. So here we have the first occurrence, meaning this. And here I have the haystack starting index, which is going to be iteratable. And also, if you remember, I also want to check if the haystack of starting index plus needle end index is equal to needle of needle end. Now, this check here over here is actually important because if what is this dot over here? Okay. Haystack starting index plus needle index should give me the final, so hello, should give me the final thing, the final letter. Now, needle of needle end is always going to give you the final letter, and haystack plus starting index plus needle index is going to be here. Actually, it's going to start here and it's going to go all the way here. And these should be the same every single time before we actually try to find the needle. So that's the only check that you need to do. Now, what I'm going to do is I'm going to say counter equals 1. Now, I'm going to say counter is going to be equal to 1 because we have already found a matching character. And I'm going to go for int index equals 1. index is less or equal than needle and index. I'm saying less or equal because here I said needle length -1. Increment the index. And of course, if a stack of starting index plus index is not equal to our needle of index, we're going to break. Else I'm just going to say counter ++. Okay, so I have incremented the counter enough times, and what I need to check is, do I have enough in counter for the needle? So the counter should be the needle's length. If counter is equal to needle.length, I'm just going to return starting index because this is where all have started. Otherwise, I'm not going to return anything, and I'm just going to continue the loop saying starting index ++. That's pretty much it. And what I need to do if I have not found anything, or if I've never ended up here, I'm just going to go outside of the loop, and I'm going to say return -1. And I think that's pretty much it. Let's run the code and see if we have found something. Needle end does not exist. And I have probably, yeah, needle end here. My mouse is doing glitchy things. Needle end index. And I hope that's the only. Okay, good. Use example test cases. And also I want to put the control flows. So I'm going to go with AABB and needle being an empty. And then I'm going to go with AA as a case stack and AAB as a needle. And then I'm going to run all of the code examples. They should be good. Needle to have one size but got 0. So the needle can never be empty anyway. Then why do we check it? Okay, let's just write B. So they say that the needle cannot be empty, meaning that this check here is irrelevant. And I placed it because they said it here on the control flow. So this is the clarification. But I guess that they never actually do this as a test case. All right, let's submit and see if that's going to be okay. All right, well, there's the problem. Now, is there anything interesting that I forgot to mention? I don't think so. That's pretty much the algorithm. I do hope that with the visual explanation, you understand it better. And yeah, stay tuned for the next one. Thanks for watching, and I'll see you in the next video. Bye.